Hello, my name is Sónia Reis. I'm a master's student in Instituto Superior de Educação e Ciências in Lisbon, Portugal. The work I'm about to present was developed during my class with the teachers Ana Cruz Varandas and Ana Paramês. It is widely accepted that in the first years of school, science education represents the beginning of the scientific methodology, simulating the curiosity throughout the observation of the world and contributing for a future reflexive, participant and interactive individual and social attitude. However, in the first years of schooling, educators and teachers usually opt for an approach more expositive and sometimes decontextualized. To promote active learning in a group of primary school students, we propose a simple approach to an everyday problem, apples with science, about apple browning and the use of the antioxidant products, with the use of hands-on activities and based on a problem-based learning, PBL, which is not a common practice in preschool and primary education schools in Portugal. Problem-based learning, or PBL, is an instructional strategy that is student-centered, facilitating the acquisition of scientific methodology and promoting curiosity. The student becomes able to observe the surrounding environment and acquires, spends theoretical knowledge, enhancing competencies such as critical thinking, decision-making, autonomy, and social awareness. The PBL methodology is one of the inquiry-based science education approaches recommended by several education entities. However, in spite of all the recognized advantage and recommendations, it still continues not to be a common practice in preschool and primary education schools in Portugal. To promote active learning in a group of primary school students, we propose a simple approach to an everyday problem, apples with science, using a problem-based learning strategy. This activity proposal is structured and oriented in different phases that we can summarize as the context, the choice of the problem question, identification of study variables, design of procedures, required materials and record instruments, predictions, activity implementation, observations, results, discussion, conclusions, evaluation, conclusion, enabling students to participate in the design and implementation of the activity, observe the surrounding world, participate and reflect on the subject of study, and develop social skills. We use it as starting point a conversation that is frequent between students that are intrigued by the difference in the browning of a chopped apple with and without lemon juice. Students should be able to ask, for example, what did I observe and what happened that made me curious about? In order to choose our question, students are simulated to discuss and share their conceptions, pre-existing ideas, and misconceptions about the observed phenomenon and guided to do research in order to improve their knowledge and to attempt to explain their observations by gathering relevant information. It's important to say that the registers or records should be made during this process. Some examples of information gathered by the students are: apple turns brown because when it is cut, air enters. Apple turns brown because of the metal of the knife. It is the cells of the apple that make it turns brown, and the apple cells release a substance when we cut it that are the possible causes. And if we put on the fruit inside water, it doesn't turn brown, and we should put some drops lemon on apple, for it doesn't turn brown, that are possibly inhibiting factors. After research, the teacher should use an adapted language to introduce and explain names and concepts that are new and necessary to guide them for the problem question, such as oxidation. Possibly explanations, such as the ones presented here, will lead to possibly questions. Some of the examples are: type of knife that we use to cut the fruit, cold prevents the apple from turning brown, it is not good to prevent the browning of apples, orange juice can prevent the browning of apples, it's like lemon. This will lead to identification of study variables and to the choice of our questions of study. We considered the question, are there any substances that avoid the browning of apples, as a possibility of choice by the majority of children, as it could hypothetically reflect their experience, and it is related to the observation of students that eat their apples with a few lemon drops added. The teacher should then lead the students into understanding the sequence of events. What are the causes? What are the effects? Guiding them into the procedures and type of records that can be used and enabling them to identify the study variables, controlled, dependent, and independent variables. In this case, to identify the controlled variable, students should ask, what will I hold constant? To identify the independent variable, students should ask, what will I change? And to identify the dependent variable, students should ask, what will I observe, measure? Before the implementation of the activity, students are involved in experimental design, in the selection of materials needed, and propose the type of records. Whenever possible, the materials and equipment should be of common use, easy to obtain, appealing, captivating, and safe for children to manipulate. The activity is subsequently implemented. Briefly, the effect of 4 different substances, plain water, natural lemon juice, natural orange juice, and vinegar, is tested in the browning of the sliced apple. The samples are labeled 1 to 5, control more for different substances, and the 5 slices are submerged in the different solutions for 30 minutes. It is important that predictions of the students, such as the ones indicated here, are registered before the implementation of the activity. This is an example of a protocol suggested by teacher and elaborated by students. Based on the observations grid, each group of students interprets and discusses the results with the class and verifies which of the proposed solutions best answers the question. This is an example of register. In the final stage, evaluation, with the participation of the students, it should be verified if the results allow to answer the initial question and a synthesis of technology, conceptual, procedural, and attitudinal, obtained and or developed through the activity proposed to the group should be done. Throughout the activity, from the initial phase of research to the drawing of conclusions, it is possible to work concepts from the areas of biology and chemistry in the language adapted to the age group. This is an example of a mind map of the topic of oxidation. We think that this proposal contributes for students to acquire new and more vast knowledge by solving real-world problems, promoting the acquisition of scientific literacy. This process is based on self-recognition, often need to learn, and enables new skills to be acquired, such as scientific reasoning and simple laboratory procedures. The fact that these activities usually involve teamwork contributes for the development of social competence and interpersonal communication. Moreover, it improves students' self-efficacy and learning outcomes, and students become conscious about their learning. These activities represent a challenge, and as any challenge, they become much more stimulating for the children. We consider that simple practical activities, such as the one present, when worked in accordance with the PBL approach, constitute an added value in the learning process of primary school children.